Now changes, we'll cover two things over here. That will be physical change and chemical change. Followed by changes, we'll see what chemical equations are. And then after that, we will see under chemical equations, we'll see two things. There'll be skeletal equations and balanced equations. Followed by that, we'll see different types of equations or reactions, and after that we will study law of conservation of mass, which will be followed by corrosion and rancidity. So these are the things that we will be covering under this chapter. If you have any confusion, you can go to the options more and can raise your hands and ask me the questions. Okay, so if there is no issue, I think we should move ahead. If you have any confusion, you can raise hand so that I can come to know that you want to say something, and then I can unmute you. Okay, now moving ahead. Now moving ahead, the first thing that we'll cover is changes. Now we all know that there are many changes that happen around us, but to classify them, we have two types of changes that are physical and chemical. So the changes around us are broadly classified into these two, that is physical change and chemical change. So now going into the details, the physical changes are those changes where there is change in the physical property. Now by physical what do we mean by physical property? Now physical property is this maybe the state of matter. Like for example, if we boil water, the water changes from liquid into gaseous form. So this is basically a physical change where the state of matter is changed. Now when it comes to chemical changes, there is change in chemical property. Now by chemical properties, what do we mean? This we'll also see with an example. Now for example, if you burn a paper, while burning the paper, after burning we are left with ash. So our earlier product was paper, and after the reaction with fire it has turned into ash, which is different from what paper was. So the chemical property, that is the composition of the original product is changed in a chemical change. Now let's see a few examples. As we know, the state change processes like melting, ice to water. This is a physical change. Moving ahead, boiling, that is liquid to vapor. This is also a physical change. Now moving ahead to the chemical changes, we have burning of paper. So what exactly happens in a chemical change is that the atoms, like we all know, every solid matter is made up of atoms and molecules. So these are bonded by some bonds. In chemical changes, these bonds are broken and new bonds are formed. So chemical changes change the identity. So this is the core line that we need to focus upon, that the chemical changes change the identity of the substance, whereas in physical change, identity remains same. Now to describe you the same, see, now if we take the example of ice, when we melt it, it becomes liquid. Now when we boil it, it becomes vapor. But all this time we are dealing with water only, that is H2O. Therefore, the identity remains same. Whereas when we consider the burning of paper, earlier it was paper, but now with the reaction, it has changed into ash. So earlier it was paper, now after reaction, it has turned into ash. So the identity of the substance is changed. So these are the basic differences between a physical change and a chemical change. I'll wait for you if you want to note down, and if you have any questions also, you can ask me about the same. Hope you all are understanding. If you have any questions, you can raise hand and I'll allow you. Seeing no hands raised, I think I'll move ahead. Okay. So yeah, sure. Wait a second. Yes, Anmol?
So how can we classify that burning of candle?
Okay, so now when we consider burning of candle, what happens is, wait, I'll clear this and I'll tell you, okay? Yeah. So what happens in the case of a candle is, suppose this is our candle, okay? Now
Yes, sir.
it is burning. So what happens is, this is wax, okay? And it is solid. Whereas the rope over here, this is the thread. Now what happens is, when we burn it, the thread changes to ash. The thread changes to ash. So this will be chemical change, okay? But
Yes.
when considering wax, this wax melts
Liquid wax.
into liquid wax. So this is just a physical
Physical.
change, okay?
Yes, sir.
So now you understand what happens in the case of a candle.
Yes, sir. So we can't classify into a single one. It is
No,
both.
it is both. It depends upon which factor are we considering. If we are considering the wax, it will be a physical change, and if we are considering the thread, it will be a chemical change.
Yes, sir.
Okay,
Yes, sir.
sure. Now let's move ahead. Okay, so now moving ahead. Now let's move ahead. I hope there are no more questions. Okay, you want, Bhavika, you want one more point about the changes. Okay, so now if you want one more point about the changes, what we can mention over here is like in physical change and chemical change, what happens is uh, no new bonds are formed. Okay, whereas in chemical changes, new bonds are formed. Moving ahead, one more point is that the property remains the same. Like as it was water, it will remain water only, no new properties will be there. But in case of chemical changes, uh, there are new properties. There are new properties of the products. I hope there are no more queries that you want. Okay. Okay, now hope it's all clear. Now let's move ahead. Now we move on to the chemical equations part. That is, now we'll see what exactly a chemical equation is. Now to see this chemical equation, firstly I'll let you know that any chemical reaction that or chemical change that we are seeing, it is denoted in some symbolic form. So this symbolic form is basically what we call chemical equation. So to go by the definition, the symbolic representation of a chemical, just a minute, the symbolic representation of a chemical reaction is called a chemical equation. So this is the basic definition of a chemical equation, that is, the symbolic representation of a chemical reaction is called a chemical equation. Now what we'll see how to write a chemical equation. How do we form a chemical equation? Okay, so I hope there is no new questions. Okay, so if you have any problem with this definition, you can ask or raise hands. I'll leave it for us for about half a minute, and you can see if you have any queries or any problem with any part of the definition. I'll help you out with it. Okay, seeing no questions, I'll move ahead. So going on the details, how to write a chemical equation. Okay, what is exothermic equation? That we'll be seeing ahead. First, let's see what exactly a chemical equation is. Though to answer your question, an exothermic equation is the equation where we have heat in the product side. Now, what is the product side for everyone? I'll mention over here. We'll see this exothermic equation further. Okay. Now see, in a chemical reaction, suppose we have A plus B giving out C. Now there are three components: the reactants, the product, and the arrow. So these are our three parts of a chemical equation. Now reactants. What are reactants? Reactants are the initial products that we have which will react together. So these are written on the left hand side, as we can see, with a plus sign in between. Now moving ahead, this C, that is product, maybe some D also is formed. So this is our product. Now products are written on the right hand side with a plus sign in between. Like there are two products that are being formed, so we write them with a plus sign in between them. And this arrow that we have, this arrow, the role of it is it always points towards the products. As we can see over here also, the arrow is pointing towards the product, and this arrow depicts the direction of the reaction. So what is the work of this arrow? It will depict the direction of the reaction. So these are the three components of a chemical equation. Now coming to your question, what is an exothermic equation? Exothermic equation is that chemical equation where we have heat on the product side. Okay, so where heat is present on the product side, it is exothermic, that is heat as product. Now similar one, we have endothermic, and in endothermic what happens is that we have heat as reactant, which means the heat is present over here. So if heat is present at the reactant side, it will be endothermic, and if heat is present at the product side, it will be exothermic. Hope it's clear. If you have any queries, you can ask, raise hands, or give me a question in the chat, or else we'll move ahead in a minute. I'll wait for you guys. If you have any questions, you can raise. You have any questions, any queries? Seeing none, I think I should move ahead. Okay, this much is clear. That's great. Now moving ahead, we will see the two that I told you, skeletal equations. We'll see skeletal equations first, and then we'll continue with balanced equations. Now, what exactly are skeletal chemical equations? Now, a chemical, firstly, I'll tell you the definition. Then we'll move ahead. So skeletal equation is a chemical equation which simply represents the symbols and formulas of reactants and products that are taking part in the reaction. So I'll write it down for you. A chemical equation which simply represents the symbols and formulas of reactants and products of the reaction is a skeletal equation. Now, to give you an idea about skeletal equation, I'll give you an example which is quoted in the NCERT also, that is the burning of magnesium in air. Now, we are discussing the burning of magnesium. So, we'll see. Magnesium, the symbol of magnesium is Mg. So, this is our magnesium. Now, this magnesium reacts with air, okay, to give out some product. So this is what the basic idea of our reaction is. So this is our basic reaction that will be occurring. Now moving ahead, we'll see magnesium has the symbol Mg. Now it reacts with air. So what happens is whenever we react anything with air, what we write is O2 in place of air. And this reaction, this arrow shows our direction of reaction, that is these two are our reactants followed by the product, and the product that will be formed in this case is MgO, that is magnesium oxide. So this is a basic, this whole is a basic skeletal reaction or skeletal equation. Okay, so if you have any questions regarding skeletal equation, you can raise hands and I'll answer your queries. Okay, so assuming seeing no queries that you have no doubts with skeletal reaction, I'll move to balanced equation, and then we'll see both of them together, that what is the basic difference, why we are studying these two separately. Okay, so now we'll move ahead. Now we'll study balanced equations. Now again, firstly we'll see the definition of the same. So a balanced equation is a chemical equation in which, like, what happens basically in any equation that we write is that we directly write our reactants with the arrow and the product. But what happens in balanced equation is that we balance the number of atoms that we are using. Like if we are, I'll show you an example, but first let me tell you the definition. I'll give you an example and I'll explain you the whole thing. So a balanced equation is a chemical equation in which the number of atoms of each element is equal on both the sides. That's why we call it balanced. So for example, we have a weight balance. Okay, so this is our weight balance that we have. Now what we do is, if we have equal weight on both sides, that is 1 kg over here and 1 kg over here, it is said to be balanced. So this is what gives it the name balanced equation. We have equal number of atoms in the reactant side and in the product side. As let me give you the previous example that we saw in skeletal equation. We had Mg plus O2 gives out MgO. Okay, this was the previous example that we saw. Now in this case, we have one Mg over here and one Mg over here. But we have two O over here, but single O over here. So we need to balance this equation. And to balance this equation, the final product that we'll get will be our balanced equation. Okay, so now I'll write the definition first, and then we'll see, and then we'll move ahead, see an example, and then take your questions. I hope no one is getting bored. If anyone is getting bored, they can raise their hands. Okay. Okay, so now, okay, now we'll move ahead, balance the equations. So going with the definition first, a balanced equation is, this is also a chemical equation. Balanced is a equation is a chemical equation in which the number of atoms is number of atoms of each element that is present in the reaction is equal on both sides. Now with both sides, I mean the reactants and the products. Okay, so this is the basic definition that we have. And to give you an idea about the same, we will take up the same example that we took last time. Now here we have Mg plus O2 gives out MgO. Wait. Okay, now we'll move ahead. We'll see this reaction, how to balance this reaction. So here we have, okay, I'll see. There's a question that we have. Hello.
Hello.
Yes.
So, what the difference between balanced and skeletal equations?
Yeah, we'll be covering that after this, after knowing what a balanced equation is. So as I compared in the starting, you saw that we had a reaction of magnesium and oxygen. We had just written our reactants and our products. But now what happens in balanced equation, I'll show you now. We have to balance the number of atoms, both the sides. Like as I told you, there are two atoms of oxygen on the reactant side, but only one atom of oxygen at the uh, product side. Okay, so we'll balance this. I'll tell you, and then after this I'll answer your query. Okay. Hello. Okay,
Hello.
I'll take your query after this.
Yes. Okay, sir.
Okay. Okay, so now we see our reactants that are Mg and O2. Sorry, this will be elements. Elements are Mg and O. So we'll have this table to give us an idea about what is happening. So this will be the reactant and this will be product. Now what happens is we have 1 mg and 2 O at the reactant side. But when we come to the product side, we have 1 mg and 1 O. So to balance the number of O here, we have to multiply this by 2. As we multiply it by 2, this 2 comes over here. So now as this 2 comes over here, this is also multiplied by 2. Therefore, this becomes 2 atoms of Mg on the reactant side. So once again we have to multiply the number of, we have to make 2 atoms of Mg at the reactant side also. So we multiply by 2 and this 2 again comes over here. So now if we see, we have 2 atoms of Mg at reactant side, 2 atoms of Mg at product side, 2 atoms of oxygen at reactant side, and 2 atoms of oxygen at product side. So we see this is somewhat balanced. So our final equation comes out to be 2 mg plus O2 gives out 2 mg O. Okay, so this is our final equation after balancing. So this is what is a balanced equation. Okay, Bhavika, I hope your doubt is cleared now.
Yes, sir.
Okay, now we'll move ahead. Now this is basically what now to tell you about the difference between the two. We saw that in skeletal equation we just had written the products and the reactants and we had no balancing. But when we see a balanced equation, what happens in a balanced equation is that we have the number of atoms of each element that is present, they are equal on both the reactant side and the product side. So this is the basic difference that is there. Now I guess this is clear. Now one more important thing that we are missing is that when we write any chemical reaction, like suppose let's take the reaction that we are working on, 2 mg plus O2 gives out 2 mgO. Now what we missed is, along with this we write the state in which it is present. Now as we see the reaction, you have an example activity in your book. We have the magnesium ribbon. As it is magnesium ribbon, so it is in solid state, so we write S to denote solid. Now it gives us uh, it reacts with O2. O2 is air that is in gaseous form, so we get gas. Now moving ahead, magnesium oxide is formed, which is white, which is basically ash, white ash, so it is also solid. Okay, if so this is a complete equation. Now let me show you. So what is present, so this is a complete chemical equation where we mention the reactants, the products. Now let's see the components. The reactants, the product, the direction of reaction, which is denoted by the arrow, Now these numbers numbers denote the balancing. Now further we have these, that is the state, physical state. Okay, so I hope you all understand what all is present in this. Okay, so now if you are asking what this equation is exothermic or endothermic or exothermic, so we know that we are burning this. If you see the activity in this equation, magnesium ribbon is burnt. So as it is burnt, we are providing heat to it. Okay, so we heat it. To burn anything, we have to heat it. So as we are providing heat towards the reactant side, so this will be an endothermic reaction. Okay, so okay, so aqueous, I'll tell you, Bhavika. Let me clear her doubt, Grisha's doubt first about the exothermic or endothermic. After that I'll move on to your aqueous question. So uh, keep in mind, whenever it's burning something, whenever we are burning something, it is endothermic, because to burn anything we need to provide heat. Hope your doubt is clear, Grisha. Now I'll move on to your problem, that is aqueous. Now whatever happens is, what happens is, I'll tell you. Mm, just a minute. Now you're asking me about aqueous. I'll give you an example about the same and then explain you. So let us take one reaction, that is Fe. Fe is iron, solid, plus zinc sulfate, ZnSO4, aqueous. Now this aqueous, this gives out zinc solid plus FeSO4, aqueous, that is iron sulfate. Okay, now as we see aqueous over here and here, this aqueous, which is denoted by AQ, means solution in water. So whenever we write any equation, whenever we write, we never write liquid. So we have solid S, gas G, and aqueous AQ. These are the three states in which our reactants or products can be. Either they can be solid or gas or aqueous. There is no liquid when we write chemical equation. It is only aqueous, which is denoted by AQ, which means a solution in water. Okay, I hope your doubt is clear. Okay, now I guess both your doubts are clear. If any of you have any problem, you can raise your hand or give me a question if your doubt is still there. Okay, I think both of your doubts are clear. Hello, Bhavika, your doubt is clear? Okay. Grisha, your doubt is clear?
Yes, sir, it's clear.
Okay, sure. Now let's move ahead. Now we'll see the different types of reaction. What we'll see are different types of reactions. Okay, now we are seeing different types of reactions. Now to name these reactions, firstly I'll write all the names, what all the reactions are, and give you a brief idea, a symbol. So the first is combustion reaction. Now I hope you all must be knowing what combustion is. Combustion basically means burning or oxidization. So to denote the same, we have some molecule AB plus O2 gives out oxide of A and B. Okay, so this is combustion. Combustion basically means oxidization. Whenever there is combustion, there will be O2. Okay, I'll give Bhavika, I'll give you this answer. So what happens is, why we burn magnesium, why we rub magnesium ribbon before burning it. So whenever we have a magnesium ribbon, suppose we have a magnesium ribbon. So what happens is, it is kept in air, and air has O2. As I told you, air has O2. So seeing, I told you there are always changes around us. So similarly, when this magnesium ribbon is kept in air, that is O2, we only consider, what is happening is we only consider O2 in this factor whenever we consider air. So a layer of magnesium, as I told you, this reaction Mg plus O2, but without heat. We don't have heat, like normal room temperature, it will not burn. We'll have magnesium oxide over it. So what happens is, there's white powder deposited on this magnesium ribbon. So what we want is, we want to burn the magnesium ribbon, but because of its reaction with air, we have, instead of magnesium, we have magnesium oxide. So to remove that layer of magnesium oxide, we have to rub it, so that the to remove we have to rub it to remove layer of magnesium oxide, which is formed because of reaction with air. Okay, I hope your doubt is cleared. Okay, Bhavika, I hope your doubt is cleared now.
Sir.
Your doubt is cleared, Bhavika?
Yes, sir.
Okay, now let's move ahead with what we were studying. And to go with all the NCERT question answers, We have the S2S app where you'll get all the answers and the questions, or answers to the in-text questions also, and the exercise question also. So you can go through them, and if you have any doubt, you can ask me during the classes. Now we have the second reaction, that is now the second reaction is combination reaction. Now, as the name only suggests, a combination reaction is where we have two different products which combine, two different reactants which combine to form a single product. So this is what a combination reaction is. Basically, combination happens over here. Now moving ahead with the third reaction, we'll be discussing these in details, so don't worry. Now the third reaction that we have is decomposition reaction. Now as we know the word decompose, which means to break down, so we have a single reactant which breaks down into multiple products. Now the fourth one is displacement reaction. In displacement reaction, what happens is, suppose this is our reactant. What happens is, one of the elements, the single element of the reactant, it displaces one of the elements in the compound to form a new compound. So this is what basically happens in displacement reaction, where there is displacement of a single element. Now we have the double displacement reaction. Now in double displacement, what happens is AB plus CD. Suppose these are our two reactants. The product that will be formed is AC plus BD. Now here A is replace A replaces sorry A replaces D and forms a bond with C over here, and B, we see that like there are two displacements happening over here. So this is basically a double displacement reaction. We'll be seeing these into details in detail. Now we also have oxidation, which as the name only suggests, it is addition of oxygen. Then we have reduction reaction. Now reduction reaction is something where there is removal of oxygen. Then we'll have a redox reaction. Yes, Bhavika, it can be AB, AD plus BC also. It's just that there are two displacements happening over there. So it can be anywhere depending upon which bond will be stronger. Okay. Now redox reaction, then exothermic and endothermic we have discussed. Exo and endo we have discussed these two, and we also have the neutralization reaction. Okay, so these are all the reactions that we will be discussing. So I guess uh, you can have a brief idea of all the reactions that you will be having in this. These are the 5 important ones, which are the basic ones. Then oxidation and reduction, these two combiningly form the redox reaction, followed by the exo and endothermic that we have discussed, and the neutralization reaction that you must have studied in acid, bases, and salts in class 8th, I guess. So we'll be seeing it again, and these are the different types of reactions that we'll be covering in this chapter. So I guess if you have any doubts regarding the same, you can raise your hands, ask me, and if you don't have any doubts, I guess we'll be ending today's class. So I'll wait for about 30 seconds. If you have any doubts, you can ask me. We'll clear the doubts. I guess there are no doubts. So I will end the video, and you can go and subscribe our YouTube channel, that is S2S classes. So there are videos, you can see the videos on this topic on our app, that is S2S classes, and you'll also get notes of this chapter free. Now we also have you can go through everything that I have taught you today. We can have a 15-20 minutes. We'll have a doubt clearance session of the same for 15-20 minutes tomorrow, and the same schedule of the same will be informed to all of you. Now you can tell your friends about these classes so that it can be helpful for them, and you can also give us a feedback whatever we can improve in the same. We'll be delighted with your feedback. Please go and check our app, see the notes, watch the videos. If you have any doubts, we'll have a doubt clearance session 15-20 minutes tomorrow, and subscribe our YouTube channel. And as study hard, be safe. All the best. Okay, no doubts, I guess. Anyone has any doubt? Hello? Hello? I guess there are no doubts, so I'll be ending the class for today then. Okay, so Anmol, you had a you don't have any doubts, Anmol? Okay, everything is clear. So you can go through the notes as I told you on the app, and if you have any doubts, you can ask me. So where are you from?
Sir, I'm from Ranikhet, Uttarakhand.
Okay, sure. If you have any doubts, you can ask me. Okay,
Yes, sir.
sure. We'll continue tomorrow, and I'll give you the doubt clearing session, the timings. Okay.
Yes, sir.
Okay. Thanks.